Hey guys! Today we're going to learn how to graph with t-charts and determine whether or not a function is linear. And these are both ideas that are in your Algebra 1 standards for Indiana. So you can look through those if you want to pause the video and do that. Your objective for the day is to be able to solve for y and then graph a function using a t-chart or table of values and then identify whether it's a line. So linear functions form lines when graphed. And if you look at the word linear, it starts out with the word line. So that's pretty easy to remember. In order to do this, you need to be able to solve for y. Well, we've been solving for x before, or n, or other variables, but when we're doing lines, we're going to solve for y. So if you noticed, we have two variables. We have x and y in this equation. We basically just want to get the y by itself. So we're going to think about that. If I want to get this y by itself, I have to get rid of this negative x. Well, to do that, I'm going to add x to both sides. So now the x's cancel out, and I get y equals, and then I just write it in order, but the trick is put the x first. So x plus 6, and I'm done. I don't have to do anything else, because remember, x and 6 are not like terms, so I cannot combine them any further. All right, let's look at number 2. Go ahead and copy this down. 3x minus y equals 1. 3x minus y equals 1. I want to solve for y. So what I want to do is I want to get rid of the 3x, so I subtract 3x from both sides. Now the 3x's cancel out, but be very, very careful. That's not just a y, that's a negative y, and that equals negative 3x, and the 1 is positive, so I put plus 1. But now, just like before, I don't care about negative y, I care about y. So I have to divide by negative 1. But guess what? There's 3 things you have to divide by negative 1. You have to divide all 3 of those things by negative 1. So check this out. I get y equals, then I have negative 3x divided by negative 1, and so I get 3x, and then 1 divided by negative 1 is minus 1. So there we go. So my final answer is y equals 3x minus 1. Now let's take a look at number 3. I want to solve for y. So here's the y term, this negative 4y. I want to get that by itself. So I have to get rid of the minus 2x. So I'm going to add 2x to both sides. Be very careful. Did you write negative 4y? I hope so. Put equals. Now we want to put the x term first. So I'm going to put 2x and then plus 3. Now we're almost there. I haven't solved for y yet. I have negative 4y. So I have to divide by negative 4 and divide by negative 4 and divide by negative 4. Now these cancel out, which is good because I'm solving for y. So I get y equals. Now remember, this is just a fraction, and it's going to be negative, and 2/4 is 1/2, so I have negative 1/2 x, and then I can't reduce 3/4 anymore, so I just put minus 3/4, and that's it. And that's how you solve for y. I think you've done that before in your previous math classes, so that should be pretty much just a review for you. All right, it's now time for your first checkpoint. Go ahead and pause the video and copy this down. Now be careful, you'll see you have to distribute on the right before you do anything else. So make sure you get this. And then when you're finished, put a big box around it. We're going to discuss it in class. All right, moving on to how to fill in a t-chart. So the first equation is y equals 2x minus 1. So go ahead and copy that down. And then what you're going to do is you're going to make a t-chart. And we're going to actually leave a middle column for the function. So we're going to put x, and then we're going to draw a line. We're going to write 2x minus 1, draw another line, and then put our y. And then we're going to start filling that in, okay? So go ahead and do that on your paper. So what this means is if x is negative 1, I want to know what y equals. So I'm going to take this negative 1 and plug it in for that x. Then when I'm done with that, I'm going to take the 0 and plug it in for the x. And when I'm done with that, I'm going to take the 1 and plug it in for the x. So I'm going to get 3 different answers. So I'm going to start back here with the negative 1. Okay, so my equation is 2x minus 1. So I'm going to take out the x and put in a negative 1. Now you did a lot of these type of problems back at Tecumseh, so I know you've got this. So 2 times negative 1 is negative 2 minus 1 is negative 3. So that's negative 3. So I have 2 times negative 1 minus 1, which equals negative 2 minus 1, which is negative 3. You see what just happened there? All right, so now we're going to try the 0. So again, I'm going to plug in a 0 for the x. So I write 2, and then I plug in a 0 minus 1. So I get 0 minus 1, which gives me negative 1. Make sense? I bet you can do the 1 by yourself. Now I'm going to plug in the 1. I have 2 times 1 minus 1. So that's 2 minus 1, which is 1. Now, what I have, remember, x and y make an ordered pair. So I have 3 of them. I have negative 1, negative 3. I should probably write that in red. I have negative 1, negative 3. Then my green one is 0, comma, negative 1. And then my purple one is 1, comma, 1. So I'm going to graph those 3 points. So I have negative 1, so I go to the left 1 and down 3. So I have my red dot there at negative 1, negative 3. So that one's done. Now I'm going to do my green one. It's 0, negative 1. So that one goes right there. And then my purple one is 1, 1. So that one goes right there. And then you can take your ruler and look. That makes a straight line. Whoops. I guess if I could draw a straight line, there we go. So that makes a straight line right there for you. All right, let's move on to number 2. So we have the function y equals 1/2 x plus 2. And you'll see that this time we have some different x values. We have negative 2, 0, and 2. And the reason is, whenever you have a fraction in front of your x, whatever that fraction is, we want to multiply that by our x because then they'll cancel out. It's going to be a beautiful thing. So let's try it. So first I'm going to start with my negative 2. So I'm going to plug in the negative 2 for the x. Now watch what happens. The 2's cancel out, so I get negative 1 plus 2. Negative 1 plus 2 is 1. Just like that. Now I'm going to plug in the 0. So the 0 goes in here. So I have 1/2 times 0 plus 2. Well, that's 0 plus 2, which is just 2. And then finally I'm going to plug in the 2 for that x. So I have 1/2 times 2 plus 2. Well, this 2 and this 2 cancel, so I get 1 plus 2, which is 3. So now, just like we said before, my ordered pair is x, y always. And so I have negative 2, comma 1 with the turquoise pen right there. Then with my blue pen, I have 0, comma 2. And then with my red pen, I have 2, comma 3. So I'm going to graph those 3 ordered pairs. So negative 2, 1. I start in the center and I go to the left 2 and up 1. 0, 2. I don't move right or left, but I go up 2. And then I have 2, 3. I go to the right 2 and up 3. So now I have my 3 points. And if you look back, you can see, if you step back and look at it, it does make a line. And so when I connect them, I have my line going through there, which is why it's called a linear equation. All right, so let's try one. We have y equals negative 3x plus 4. So we're going to make our own t-chart here. So I'm going to put x, then my equation is negative 3x plus 4, and then I'm going to put my y. Okay? So I don't have a fraction. So since I don't have a fraction in front of the x, the easiest 3 x values are negative 1, 0, and 1. So I'm going to pick negative 1, 0, and 1. All right, so starting with negative 1. I'm going to take my equation and take out the x and replace it with a negative 1. And negative 1 times negative 3 is positive 3 plus 4 gives me 7. Okay? Moving on. Now I'm going to replace the x with a 0. So I have whoops, supposed to be orange. So I have negative 3 times 0 plus 4. Well, anything times 0 is 0. So I have 0 plus 4, which is just 4. So my ordered pair there is 0, 4. And then finally, I have 1. So I have negative 3 times 1 plus 4. So I have negative 3 plus 4, and that gives me positive 1. So those are my three y values. So I have 3 ordered pairs. So I really have, I'll write these down here at the bottom, I have negative 1, 7. I have 0, 4. And I have 1, 1. Make sure you understand where I'm getting my ordered pair from. So I have negative 1, 7. So I'm going to go to the left 1 and up 7. 1, 2, 3, 4. Right there. Then I have 0, 4. That means I don't go right or left, but I go up 4. Then I have 1, 1. I go to the right 1 and up 1. Now, whoops, that didn't change. Now, if you take a look back, you'll see that that does make a line. So then you'll take your ruler and you'll connect it. And we have our linear equation. We have our line. We have our line. All right, number 2, y equals negative 2x plus 3. So go ahead and copy that down, and we're going to make another chart. So we're going to have 3 columns here. So we're going to have x. We're going to have negative 2x plus 3. And we're going to have y. So remember, since the x doesn't have a fraction in front of it as a coefficient, we're going to use the 3 simplest x values, which are negative 1, 0, and 1. So when I plug in negative 1, I have negative 2 times negative 1 plus 3. Negative 2 times negative 1 is positive 2, plus the 3 gives me 5. So my first ordered pair is negative 1, 5. And I'm going to go ahead and write it right down there. Now I'm going to move on to my next ordered pair. I'm going to pick 0. So I have negative 2 times 0 plus 3. Well, negative 2 times 0 is just 0, plus 3 gives me 3. And then I move on to my orange. I'm going to use the positive 1. So I have negative 2 times 1 plus 3. So I have negative 2 plus 3, which is positive 1. So I have my 3 ordered pairs. I have negative 1, 5. I have 0, 3. And I have 1, 1. So I'm going to graph these 3 ordered pairs. I'm going to start with my negative 1, 5. So I'm going to go to the left 1 and up 5. Moving on to 0, 3. I'm not going to go right or left, but I'm going to go up 3. Then I have 1, 1. I'm going to go right 1 and up 1. And if you step back and look, you can see it does indeed make a line. And then you connect them. Oh, that one's not very good. You connect it to make a linear function. So I'm showing a line on my graph, and I made my t-chart. All right, here we go with number 3. So this time we have a function 2x plus y equals 8, but there's a little bit of a problem. We haven't solved for y. So now we have to use the skills we did previously in the video before we make our t-chart, because we can't make a t-chart until we've solved for y. So in order to solve for y, I'm going to subtract 2x from both sides. Those cancel out, and I get y equals. And then I told you that little trick about putting the x term first. So I put negative 2x plus 8. Now I've solved for y. Now I make my t-chart. So I have x, negative 2x plus 8, and y. Now I look at my x term, and the coefficient does not have a fraction. So my easiest 3 x values are negative 1, 0, and 1. So let's start with the negative 1. I'm going to take out the x and replace it with a negative 1. So I get 2 plus 8, which is 10. All right. Moving on to the 0. I take out the x and put in a 0. So I get 0 plus 8, which is 8. And then one more, I plug in the 1, so I have negative 2 times 1 plus 8. So I have negative 2 plus 8, which is 6. So now I have 3 ordered pairs. I have negative 1, 10. I have 0, 8, and I have 1, 6. So I'm going to graph those 3. Starting off with negative 1, 10. I'm going to go to the left 1 and up 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And I'll just put it right there. Now I have 0, 8. So I don't go right or left, but I go up 8. 3, 4, 5, 6, 7, 8. And then I go to the right 1 and up 6. 1, 2, 3, 4, 5, 6. Now look back at, whoops. If you look back at it, you'll see that those 3 dots form a line. And so when I connect them, there's my graph of my line that was represented by my linear equation. All right, here we go. So I think you should be getting the hang of it by now. So number 4 is 4x minus 3y equals 6. So again, they haven't solved for y for us, so we need to do that. So I'm going to subtract 4x from both sides. The x terms cancel out. And be careful here, I've got negative 3y equals, I'm going to put my x term first, so negative 4x plus 6. Now, the y is still not isolated, it's still not by itself, so I have to divide by negative 3, and I must do that for each of the terms. All right, the negative 3's cancel out, so I get y equals, negative divided by negative here is a positive, so I get 4/3 x, and then I have 6 divided by negative 3, which is negative 2. So that's my equation. If you aren't sure how I got that, please pause the video or rewind it and go back and look at it again. So now I'm going to make my t-chart. So I'm going to have x. I'm going to have 4/3 x minus 2. And then I'm going to have y. All right. So in this case, I have a fraction in front of my x. So I bet you're thinking, you know what 3 numbers I should use for x's, right? I want the denominators to cancel out. So I'm going to use negative 3. I'm going to use always 0. And then I'm going to use positive 3 because that's going to make those denominators cancel out. So let's check it out. So I have 4/3 times negative 3 over 1, obviously, minus 2. Look what happens. Those 3's cancel out. So I get negative 4 minus 2, which is negative 6. So my first ordered pair is negative 3, negative 6. Okay, now 0. I have 4/3 times 0 minus 2. Well, that's just 0 minus 2, so that's negative 2. So my second ordered pair is 0, negative 2. And then finally, I'm going to use a positive 3. So I have 4/3 times 3 minus 2. My 3's cancel out, so I have 4 minus 2, which is 2. So my third ordered pair is 3, 2. Now, if you need to pause the video to catch up, go ahead and do that. But I'm going to move on to graphing here, so when you're ready, join me. So my first ordered pair is negative 3, negative 6. I'm going to go to the left 3 and down 6. That lands right there. Now I'm going to use my red one, which is 0, negative 2. So I'm not going to go right or left, but I'm going to go down 2. And then finally I have 3, 2. I'm going to go to the right 3 and up 2. Now if you step back and look at it, it does form a line, doesn't it? So when I connect it, I'm going to get that line I was looking for. So I have a linear equation. And it made a graph of a line. Now we've come to checkpoint 2. So go ahead and copy this equation down, and I want you to solve for y, make a t-chart, and then graph it. And then we'll be talking about this in class. All right, so you might want to pause this slide to make sure you can get all this written down. How to determine if a function is linear. Number 1, there's no exponents other than 1 on the variables that are in the equation. Number 2, it can't have a third variable that's different from the other 2. Number 3, you can't multiply the variables together, so they're not going to appear like xy. It could be x plus y, but you can't multiply them for xy. Number 4, you cannot divide by a variable. So in other words, you cannot have an equation that has an x or a y at the bottom of a fraction. So you cannot have that. You cannot have a variable under a square root. So if you have something like that or something like that, those are not lines. And you have to have one or two variables. All right, so let's take a look at this. And we're going to look at each of these situations and we're going to make a determination as to whether or not they're linear. So the first one, y equals 3x minus 4. Well, my variables have the exponent of 1 because remember the exponent of 1 doesn't have to appear, so that's okay. It doesn't have 3 variables, so rule number 2 is okay. Number 3 says I can't multiply them together, but I haven't. Number 4 says I can't divide by a variable, but I don't even have any fractions. Number 5, I can't have any square roots with a variable under them, and I must have 1 or 2 variables. So is this one linear? Yes. All right, moving on to the next one, y equals x squared. No exponents other than 1. Uh-oh. This is not a function, and it broke rule number 1 because it had an exponent other than 1 on the variable. All right, moving on to y equals negative 5. So if I look through the rules, I'm okay with number 1. I'm okay with number 2. I'm okay with 3. I'm okay with 4. I'm okay with 5. And it has to have 1 or 2 variables. That has 1, so yes, this is 1. And for the same reason, y equals 7 is also 1. Because if I have a line y equals negative 5, it's going to be a line that looks like that. And if I have x equals 7, it's going to look like, it's going to be like that. Okay, so yes, I don't have to have 2 variables. All right, moving on to the next one. Y over x equals 12. Well, that one breaks the rule. Can you figure out which one it breaks? Yep, you're right, number 4. We can't divide by a variable. So this one is not 1 and it breaks rule number 4. All right, moving on. We have 3x minus 4y equals 8z. Well, we're okay on all, well, we break one. You see which one we break. This is not a function because we have 3 variables. It breaks rule number 2. All right, moving on to number 3. Okay, rule number 1, I'm okay with that. I don't have 3 variables, so I'm good with rule number 2. I haven't multiplied them together, so I'm good with rule number 3. I didn't divide by a variable. I divided by 2. That's okay, but I can't divide by a variable. I can't have a variable under a square root, and I have to have 1 or 2. So this one's good. This one's yes. This is a line. Okay, moving on. Negative 2y equals 3 over x. Well, I just said 3 over x, and the rule says you can't divide by a variable. So this one, no, it breaks rule number 4 because I can't divide by that variable. All right, next one, square root of x plus 1 equals 3. Well, I just said it. I can't. Rule number 5, you can't have a variable under a square root. So this is no, it breaks rule number 5. What about the next one, xy plus 3 equals 10? Well, look at your rules. It's not a line, it breaks rule number 3. Number 5, the next one I have 5 minus 3x equals negative 8y plus 4x. So my variables are okay because the exponents are 1 and 1 and 1. I don't have a third variable because I have x, y, and x. Even though there's 3 variables, I'm going to combine these x's into one term. So that's okay because I don't have x, y, and z. That would be bad. I have x, y, and x. That's okay. I haven't multiplied my variables together. I haven't divided by variables. I don't have square roots. So I'm okay. So this one's yes. And then the last one, well, he breaks rule number 1, doesn't he? I can't have these exponents, so that means it's not a line.